All right, guys, welcome to Unit 11. Oh, that should say, let's see, that should say Unit 12, my bad. Unit 12, Lesson 1. Today, in this unit, basically, we're going to be graphing the trig functions. So, we learned what trig equations are, we've learned how to solve trig equations, and now we're going to look at how to graph trig functions. So, we're going to break this up over a few days. The first day, we're going to work on sine and cosine. So, let's go ahead and jump in and get started here. So the first thing we'll do is we will do a little exploratory exercise here. Let's complete this table. All right, so if cosine of theta equals this function, which I'm calling f of theta, and I want theta to equal 0, we're going to plug that in. So I'm replacing the theta with 0. Now, what is cosine of 0? That is 1. So f of 0 is 1. So when we plug in 0, I get 1. Let's graph that point as well. Now, this is the x-axis here. I'm going to call that my theta axis. And my y-axis here, I'm going to call that my f of theta axis. Okay, so in other words, this is my horizontal number and this is my vertical number. So I'm going to go over 0 and up 1, which is right here. All right, let's repeat that with the next one. Let's plug in pi over 2. So cosine of pi over 2 is equal to f of pi over 2. Now cosine of pi over 2 is 0. And so I end up with 0 here. So my horizontal number is pi over 2, so I'm going to go over that much. And then I'm going to go up 0, so that one's actually right on the x-axis, or the theta axis, I guess we should call it in this case. And we're just going to repeat that for the other ones as well. So we're just going to plug numbers in, get an answer, put it here, and then graph the point. So let's do cosine of pi. Cosine of pi is -1. And so at pi, we have a -1 value. Let's do 3 pi over 2. And that would be 0. Where am I getting these numbers from? Well, hopefully you guys know that. It's on your unit circle. Remember, cosine is the x value, so you find this angle on the unit circle and you look for the x coordinate at that point, which is 0. And we'll do one more. Cosine of 2 pi is equal to f of 2 pi. Cosine of 2 pi, the x value at 2 pi is, no, it's not 0, my bad. It's 1. All right, so at 3 pi over 2, we have 0, so I'm going to go back to the x-axis there, and at 2 pi, we're up 1. Now, as you guys are looking at this, you might think, oh, it makes a V shape. Well, no, it's just because I'm not going to graph an infinite number of points, first of all. So it actually is not a V shape. It's actually a smooth curve. So, oops, didn't want to do that. Let me undo that last thing. There we go. It's actually a smooth curve, so it's not like straight lines that connect at a sharp point. It's more like this. Okay, so it's a smooth curve. Now, we would see that a little bit more obviously if we were to plug in more points like between 0 and pi over 2, but I just didn't want this to be horribly laborious, so I'll just tell you it's a smooth curve. It's not a V shape. Second of all, as you guys know, cosine functions and trig functions of all kinds always repeat their answers. So notice that 2 pi and 0, those are coterminal. When you're looking at your unit circle, 0's here, and so is 2 pi. And that's why they have the same answers. If I were to keep going, I would just be finding more coterminal angles that match this, then this, then this. And so what we end up with is we end up with a pattern that just repeats on this side. It goes 1, 0, -1, 0. 1, 0, -1, 0. And it's just going to keep repeating every time I go up by the same amount every time. And so as a result, this shape gets repeated on the graph. So if I were to be going backwards, it would look like this. And it never stops. It just kind of keeps going, actually. And so sine functions, cosine functions, actually just look like a wave, okay? They just look like a wave, right? So I would extend it on your graph just so you can kind of see. But basically what you're noticing here is that every time you have a dot, if you go over 1 pi over 2, then you go down 1 space. Over 1 pi over 2, down 1 space. And then after that, you go over 1, then up, then over 1, then up. And it kind of creates this wave pattern here. Now, this piece right here is what I'm going to call the basic shape. That's the basic shape of cosine. And some things that I want you guys to notice about it is that it starts at 1. And goes down from there. And then it continues its pattern. So it starts at 1 and then it goes down and then it continues the pattern after that. Okay, so it's down 1, up 1, up 1, down 1, up 1, up 1, down 1, up 1, up 1. Okay, and so you just get that wave pattern as a result. Okay, now here's one for you guys. I want you guys to do the same thing but with sine. Okay, so pause the video here and see if you guys can create a graph of sine. When you unpause the video, you will see the results. All right, so this is what your sine graph should have looked like. Sine is the y value, so if you find this angle on the unit circle and you find the y value that goes with it, you would get the output here, which is 0. So my first point is 0, 0, which is located here. If you plug in pi over 2, you get 1, pi you get 0, 3 pi over 2 you get negative 1, and 2 pi you get 0. And you get these other dots as a result, so it looks kind of like this. And that's what I'll call the basic shape of sine. What's kind of cool is it looks like an S for sine, doesn't it? Kind of like a backwards S, but all right. So there's that. Now it kind of has the same pattern. It just starts off at a different place. So remember with cosine, it started at 1. Cosine started at 1, then it went down 1, up 1, up 1. So you actually have the same kind of shape going on. It's just that sine starts at a different place. Sine starts in the middle here at 0. So it goes up 1, down 1, down 1, up 1. Up 1, down 1, down 1, up 1. And it will just keep that pattern going on forever as well. Okay, so their basic shapes look different. You know, so cosine looked more like this, right? It looked like a U almost. Whereas the sine shape looks more like a backwards S. But really, if you just let them both continue on forever, they kind of look exactly the same. The only difference is where they start. Cosine starts up here, sine starts here. But other than that, they pretty much have the same pattern. From the middle spot, you go up 1, and you go back down 1, and you go back down 1 again, and then back up to the middle again. So it just repeats that pattern over and over again. And those are trig functions. Okay, so comparing and contrasting sine and cosine function. Sine starts at 0, which is what we call the midline. The reason we call it the midline is because on a sine wave, it's the line right in the middle. Sine, as we said, takes on this S shape. So this is what a sine shape looks like if you look at the basic shape, and it starts right here at the midline. So sine starts at 0, or in other words, the midline, and after that it goes up, and then it continues the pattern it's supposed to. Cosine starts at 1. Cosine starts at 1. So as you guys remember, the basic shape for cosine was more like this U shape here. So cosine starts up high. Cosine starts at 1. And after that, it goes down. Now, instead of saying it starts at 1, I'm going to say it starts at the max, because that's the highest level of the graph. That doesn't go past that, so it's the max. So sine starts at the midline and goes up from there. Cosine starts at the max and goes down from there. And after that, they both follow the same pattern of rises and falls. It's always one space up for the midline, then back down to the midline. One space down from the midline, back up to the midline. And just kind of creates that pattern. The domain, they both have all real numbers. Domain, in case you guys forgot, is all the possible values of x. Well, in this case, my input axis, the horizontal axis is 0. Well, there's no angle you're not allowed to plug into for sine or cosine. So you just kind of get this pattern. It goes on forever. You always have an answer. It's somewhere off in infinity. Okay, But the range is restricted. Now, this is something we don't talk about quite as much, but the range is all the possible y values, the height of the graph. Well, as you guys can see, the height of this graph is bound between this line and this line here. The graph doesn't go past that, okay? So the range is always between -1 and 1. However, we'll see later on that we can make those values different, okay? So there's that. Let's go ahead and, so that's comparing sine and cosine. They basically have the same pattern. They have the same domain. They have the same range. The difference between them is just where they start, okay? All right, let's go ahead and move on to the next slide here. So this gives us some basic definitions about all the parts of a sine and a cosine graph. Okay, I'm going to lower my screen here a little bit so you guys can see more. All right, so as I mentioned, the line that goes through the middle here is called the midline. Now, the line up here, now when you graph these, you actually won't see these lines, but we're just kind of visualizing them. The green line, the red line, the blue line, we're just visualizing them being there. The real graph is this wave, but the top bar here is what we call the maximum. The bottom bar is what we call the minimum, and the middle here is what we call the midline, okay? Some other vocabulary. The distance from the midline to the max, or it could be the distance from the midline to the minimum as well, because they're both the same length, is what we call the amplitude, okay? It tells us how high the graph goes. It's not always 1. On the graphs that we just completed, they were equal to 1. The amplitude was only 1. It was at 0, and then it went up to 1, and then it came back down. But the amplitude does not always have to be 1. We'll see why in a minute. Another thing to pay attention to here is something that we call a period. A period, we learned about this before. A period is how long it takes for you to go around the unit circle. So for sine and cosine, you get repeating answers after 2 pi. So their period is 2 pi, or you could say 360 degrees. But for tangent, you guys might recall, it has a period of 180. Okay, so it has a shorter period. Now in a graph, what does a period mean? Well, a period is that basic shape I told you about. So like here's a sine shape, right? So there's one period. That's a full sine wave where we start at 0 and we end at 2 pi. But that same shape gets repeated over here, so that's another period, so it gets repeated. That basic shape where you get one full cycle in is what we call a period. All right, next, domain is all real numbers. We've already mentioned that. You can plug in anything you want to into a sine and cosine function, and you'll always get an answer for it. But the range is limited. The range is always between the maximum and the minimum values. And those can be found by taking your midline and subtracting it from the amplitude. So if you're at your midline and you add the amplitude to it, you get the max. If you're at your midline and you subtract the amplitude, you get your min. Okay, but that is the range and domain. So some nice vocabulary there for you guys for sine and cosine. Let's move along here. Let's review our transformations a little bit. It's been a while since we've done this, but if you have a function and you multiply it by a, then, and let's say a is a number that's bigger than 1, then what happens is your graph gets stretched. Okay? If you are multiplying by a, and a is a number that's between -1 and 1, in other words, it's like a fraction value, then in that case, your graph gets compressed. It'll look flatter. Okay, so let's say that f of x is something that looks like this. Then if you multiply it by something bigger than 1, it's going to look more like this. It's going to get stretched. It's going to be taller and skinnier. Whereas if you multiply it by something between -1 and 1, it's going to look shorter and fatter. It gets compressed, right? Another type of transformation that we talked about was vertical shifts. So if you were to add to it a number, that will shift your graph up. It doesn't change the shape of it, it just moves it up. Okay. Likewise, if you subtract a number from a function, it will shift it in a downward direction. So we talked about a lot of other transformations as well, but these are the only two that we really need to care about today. And we're going to see how those come into play as we're talking about trigonometric functions here. So here we go. All right, so we know that sine usually just wobbles like this, right? And it stays between +1 and -1 with the midline at 0, right? But we can change all that. If I multiply by a number, a, it will either stretch my graph so that it gets taller, or it will compress my graph so it looks flatter, okay? And so basically what this A is it's your amplitude. And that works for both of these. The A basically just tells you how tall your function is going to be from the midline. So the A is the amplitude. Now another thing that we saw was that sine and cosine both usually are centered at the midline, which is 0. So that's where they're at. But if you were to add, that's 0 by the way, if you were to add a number to your function, then your graph is going to get shifted upwards and it's going to change the midline. And so when you add k or subtract k, basically what k ends up giving you is the midline. So when we're graphing sine and cosine functions, whatever number you're adding to your sine and cosine, that's going to be your midline. And whatever you're multiplying your sine and cosine by, that's going to be your amplitude, the distance from the midline to the max or min value. Okay, so let's keep those things in mind. And here are some steps now for graphing sine and cosine functions. So the first thing we're going to do is we're going to identify and graph our midline. Then we're going to use our amplitude to find our minimum and maximum. So once I know where my midline is at, all I have to do is add my amplitude to it and subtract my amplitude from it to find my minimum and maximum values. And then we're ready to draw our curve, but as we do that, we have to remember that sine starts at the midline and goes up, cosine starts at the max and goes down. So let's put all the stuff that we just talked about to work for us to actually create a graph now. All right, so the first thing we want to do is we're going to set up a graph here. I'm going to draw an x and a y axis, and for today, these numbers will eventually change, but for today, we're always going to use the same numbers. You could do radians or degrees. I'm going to use radians on the first example, and then I'll do degrees on the next one. It doesn't matter which pair you use, but that's what we're going to do. So we're going to call this our y-axis, and we're going to call this our theta axis, and we're going to graph. So you're always going to start by setting it up with these numbers. So the first one we'll graph is pi over 2, then pi, and then 3 pi over 2, and then pi over 2. I'm sorry, 2 pi. Basically, we're just going up by pi over 2 every time, okay? Now, that's how we're going to set up every problem. It doesn't really matter which one we're working on. Eventually, we will change these numbers. These numbers will not stay the same, but for the first few lessons, they will. Now, if you wanted to write these in degrees, it would be 90, 180, 270, and 360. But just so my graph doesn't look all messy, I'm going to get rid of those. All right, so let's begin. So according to our steps that we just looked at in the last page, we want to start by finding our midline. Now, as I told you guys, this number right here, the number that you're adding or subtracting, that is your midline. So that's going to be on the y-axis. We're going to go down 2. And I'm going to draw a dotted line that goes through -2, just like that. That's my midline. I'll label it. You don't have to label yours, but I'm going to label it. Next, we're going to use our amplitude to find the max and the min. This is my amplitude. And what that basically means is I'm going to go up 3 from the midline and down 3 from the midline and draw 2 more little dotted lines. So starting from my midline, -2, I'm going to go up 3 and put another dotted line. That's going to be my max line. And I'm going to go down 3 and put another dotted line. And that's going to be my min value. Okay, so step 1, graph your midline. Step 2, use the amplitude to find your max and min. Now step 3, we're going to start our curves here. So this is a cosine function. So cosine always starts at the maximum. So at 0, we're going to be at the maximum line. So I'm going to put a dot here. After that, it's going to follow the pattern. We're going to go over 1, down to the midline, over 1, down to the minimum, over 1, back up to the midline, over 1, back up to the max. And there's that. Now I'm only going to be looking really picky at the first cycle of this, the first period, but technically, as you guys know, the graph does just keep going on after that. Okay, but when I'm grading these, I'm mainly just looking at this, making sure that your dots are in the right place, your midline and max is in the right place, and that you have the right angles labeled on your axis. So there's that. So let's review the steps again. Graph your midline, dotted line here. Use the amplitude to find, step 2 is use the amplitude to find the max and the min. Step 3, based on the function, since it's a cosine, I start at the max and I follow my pattern. Okay, let's go ahead and do number 2. And let's see if you guys can predict some things this time. What's step 1? Step 1 is to draw a graph. I probably should have wrote that one down. I didn't. I'm going to go with degrees this time, though. 90, just because I want to show you that you can. It doesn't really matter if you do radians or degrees, but there's our degrees. All right, so now that we've got our graph set up, now what's step 1? Step 1 is to graph your midline. And what is the midline? The midline is 2. So I'm going to go up 2, and then I'm going to draw a dotted line. What's step 3? I'm sorry, the next step, step 2. Step 2 is to identify your amplitude and use that to graph the max and min. So what's my amplitude? My amplitude is 3. So graph your max and your min now. You might want to pause the video for this because you might need a moment. But here's how you would do it. You'd go up 3 and down 3 from your midline. 1, 2, 3. So, and then you put some dotted lines. And there's that. All right, next we're going to do our graph, and that part's going to be a little bit tricky for you, maybe. We'll see. So we always start horizontally here on the y-axis, okay? Once again, that will change eventually, but for today, we're always going to start on the y-axis. But where do we start on the y-axis? Well, since this is sine, where does sine start? Sine starts at the midline. So we're going to put our dot right here. And then after that, it goes upwards. So over 1, up 1. And then just continue your pattern. Over 1, down 1. Over 1, down. When I say down 1, I don't really mean one space. I mean, I should say over 1, up to the max. Over 1, down to the midline. Over 1, down to the minimum. Over 1, up to the midline again. And we should have our basic sine shape here, which looks like a backward S, right? Of course, the graph does go on, so we'll just kind of sketch the rest of it, roughly speaking, but the part that I will be grading is this portion of it. All right, let's go ahead and graph the last one. This might be a good opportunity for you guys to kind of try to do it on your own here. So I'm gonna change it to, I don't really like this example. I'm gonna change this a little bit. I'm gonna change it to let's do 1/2 for that. All right, so here we go. Draw your graph. Like how would you set up your graph? You could use radians or degrees, but you pick. If you need to pause the video to do that, go ahead, but here we go. It should look like this. I'm going to go with radians. All right, next supposed to graph my midline. Where's my midline? It's at 2. I'm going to go up 2, put a dotted line there. Next, I'm supposed to find my max and min by using my amplitude. My amplitude is a half. So if this is 1, this is 2, then 3 would probably be here, but I only want to go up a half. So I'm going to go up halfway there. I'm going to draw a dotted line like this. So this is going to look like a pretty squished little graph. And we also go down a half from our midline. So down a half would be about there. All right, now this is the real test of where you guys are at right now. Where do you put your first dot? It's a cosine graph, so cosine always starts at the max. So where do we put our dot? We always start at 0, and we're going to be on the maximum line at 0. After that, you follow your pattern. So it goes over 1, down to down to the midline, over 1, down to the minimum, over 1, back up 1 to the midline, and then over 1 back up to the top. And then your cosine graph is going to look a little bit flat. And why does it look flat? Well, there's 2 reasons it looks flat. One reason is because my amplitude is small. It's like a vertical compression. But another reason why is because I actually stretched out this axis probably a little more than I should have. But there's that. So we have our basic shape here. And of course, as you guys know, it just kind of keeps going after that with the same pattern. So, all right, so I'm going to go ahead and let you guys do a student practice here. So pause the video and try these 3 problems. All right, guys, so here's your graphs. Now, I didn't put the numbers on the axis just because I'm working with very little space here, so cramming them in there would be a little inconvenient. But just want to make sure that you guys check your work here now. It's kind of hard to check your work because maybe you sketched it a little bit longer than me or shorter than me, and so they may not look the same. So here's some of the things you want to check. So go through this with me here. For number 1, your maximum line should have been at 5. Your minimum line should have been at -3, and your midline should have been at 1. So that's 3 things you need to check. Also, did your graph start here? Did it start on the maximum on the y-axis? And does your basic shape look like that afterwards? Then you're probably good. Okay. Let's go ahead and take a look at number 2. Your maximum line should have been at -1. Your minimum line should have been at -3. And your midline should have been at -2. And once again, at 0, your graph should have started at 0, -1. And from there had the basic cosine shape following it. And then finally, on number 3, your maximum should have been at 4. Your minimum should have been at -2. Your midline should have been at 1. And since this is a sine graph, you should have started at the midline. So your starting point should have been at 0, 1, and you should have went up after that, forming this backwards S shape. Okay, and that's pretty much it. So let's go ahead and move on to the next part. We're going to introduce one other transformation now. As you guys may recall, anytime you have a function, if you take that function and you multiply it by a negative, what it does is it flips it upside down. So if f of x usually looks like this, then if you put a negative in front of it, it's going to flip it upside down. Okay, and the same thing applies to sine and cosine. So now usually with sine, as you guys know, it starts at the midline and then it goes up to create the pattern, right? But if you flip this graph upside down by putting a negative in front of it, then actually it's going to start at the midline and then it's going to go down. So then it'll look like a real S instead of a backwards S. Cosine, as you guys know, usually starts at the max and then goes down from there. But if you put a negative in front of it, it's going to flip it upside down so that it starts at the minimum and goes up. So when you have a negative in front, it's basically going to change where you start your graph. So let's do some examples that involve that now. All right, so to begin with number 1, we have this guy. The first few steps are basically the same. The only thing that's going to change is the last step where you start actually graphing the curve. So let's find our midline. My midline is 3. I forgot to put my axes on here, or my numbers, I mean. Let's do that. All right, there we go. So my midline is -3. There's no amplitude there, so we can assume that the amplitude is 1. And so that takes us up to -2 for the max. And if we go down 1 from with our amplitude, that takes us to -4 for the minimum. All right, now what do we do with sine? Well, on our last slide, we saw that if you have a sine with a negative being multiplied in front of it, you start at the midline and go downwards. So I'm going to start at my midline, and then I'm going to go down. So over 1 down to the minimum, over 1 back up to the midline, over 1 back up to the max, over 1 back down to the midline, and then connect your dots. And there it is. All right. And if you wanted to continue the graph, it would look like this, of course. All right, let's go ahead and do the second one, number 2. Number 2, you'll notice that there's no number being added or subtracted to the cosine. That means it's 0. So that means that my midline is going to be 0, which is just basically the x-axis or the theta axis, we could call it. I'll do radians this time. Just going to change it up a little bit. So this time my midline is 0. So I'm going to just basically put a dotted line right on the x-axis this time. So that's my midline. My amplitude is -2. Well, actually, it's just 2. So I'm going to go up 2, put a dotted line. Then I'm going to go down 2, put another dotted line to find my maxes and mins. So I've got my midline in pink. I've got my maxes and mins in green, and now we're ready to graph the curve. I'll do that in blue. Now cosine typically starts at the max, but whenever you have a negative in the front, cosine starts at the minimum instead. So let's do that. Here we go. So I start at the minimum this time, over 1 up to the midline, over 1 up to the max, over 1 down, back down to the midline, over 1 down to the minimum again, and then we draw our curve. And then once again, if you want to elongate the pattern, you can. Yeah, you should technically, because it goes on forever, it never stops. All right, and so that's that. So we saw now with this second example what the negative multiplier in the front does. It causes the graph to flip and do the opposite of what it usually does. So with sine, instead of starting at the midline and going up, if there's a negative, it starts in the midline and goes down. With cosine, instead of starting at the max, if there's a negative, it'll start at the minimum. All right. Other than that, you just follow the basic pattern. So let's go ahead and toss one more of these at you guys here. I'm going to pause the video and give these 2 a try. All right, guys, so here's your answers. Once again, let's check our work. First of all, your midline for number 1 should have been at 1. Your maximum should have been at 1.5, and your minimum should have been at 0.5. Now your graph, since we have a negative multiplier in front of the cosine, should have started down here at the minimum and gone up from there following the usual pattern. For number 2, your midline should have been on the x-axis, or the theta axis, we should say. The maximum should have been at +2, and the minimum should have been at -2. And since we have a negative multiplier with our sign, we should have started at the midline and gone in a downward direction, creating this basic shape here. All right, and that is that. So I think that will end our lesson for the day. So hopefully that was helpful, and we'll put this stuff to practice in class next time I see you. Till then, have a good one. Bye-bye.